Okay, we're in section 20 of the notes. This is a section on radicals, a tough section. I realize that. Basically, we talk about simplifying, or at least initial simplification. We talk about approximating roots. Um, then we talked about addition, subtraction, multiplication, dividing, and conventions that we had. We went through a bunch of examples. Hopefully you've studied that material, reread the notes, looked at the problems again, maybe looked at the videos again if you need to do that. But at some point, you need to get ready to do things on your own. And so we worked through, and it goes a long section. I know we worked through a bunch of problems here. I think we worked through 19 problems. Let me make sure of that. Yeah, we went through 19 problems. And then, of course, we're hoping that you're saying, I want to try myself. And we really do want you to try. So what we're going to do now is I'm going to do another share with you and start to do the homework. All right. So I'm going to share another screen with you. I'm going to share the whiteboard with you now. And give me a second to warm that thing up. And I'm going to start with a blank sheet of paper. And again, what I'm going to claim to you is that we're going to be doing, just give me 1 second here. I'm going to clean something up. We're in section 20 of the notes. And we're doing the homework. Again, the expectation is you have the notes in front of you at this point, and you've got the homework in front of you. That means you've a clean notebook with your problems done. So number one, I'll go through it with you. What do they want me to do? Simplify this guy over here. I'll write it down for you. It's x cubed and y4 and z9. I realize a lot of students are confused by these problems over here. When you simplify, we have conventions, and this is square root, so no perfect square factors can be contained in that radicand. So I'll just pull them out. So x squared is contained in x cubed. Y4 is a perfect square. And let's take a look at Z9. I'm going to say, I hope you know that perfect squares they're multiples of 2, 2, 4, 6, 8. So I'm going to say Z8. And we left off with a Z over there. So I'm going to take the square roots of these things over here. Again, we're assuming these are nice problems. In other words, the x is a positive number. But again, when you take 119, what I'm telling you is not entirely true. So this is x, y squared, and then it's going to be z4. Square root xa. Put a box in this. Get my little green pen out or my red pen out. And what I'm going to do is look at it, see if I got it right. So I'm looking at the answer key. It's in blue, right? X. Then I got y squared, z4, square root of xc. Looking good. Let's go to number 2. And again, I realize for some students it goes too quickly. If it is, you probably haven't done the study and the homework yet. You can always come back at the end of the week to view these videos here. Put number 2 down for you. And what I'm seeing over here, 2 square root of 2x plus 11 square root of 2x. So what I'm going to claim over is that these are two terms, right? This is a term over here, and this is a term over here. What they want to do is combine those two terms. The way to do that are they like terms. A like term has identical, radical, and variable parts, and this certainly does. So what I do, just add their coefficients together. So 2 and 11 would give me 13. Now 13 what? Root 2x. Again, I can't say this enough times. Look at the answer key. Oh, I'm sorry, I copied wrong. I got to go back and erase this. I'll tell you what I copied wrong. 2. I did that wrong. I'll put this over here. What was number there was 3. Right? Sorry about that. I did it again. 3. What am I going to do? Same thing as before. Like terms, there's two like terms. They have identical variable radical part. Add their coefficients. You get 14. 3 and 11 is 14. Root 2x. Put this in a box. Get my red pen out. Look at the answer key, and I'm staring at that. All right, let's go to number 3. Number 3 is the simplification problem. What am I seeing? A cube root now. Again, we've covered this in the notes. Hopefully you're at this stage where you're willing to try it on your own. I do see the answer. And I want to point out we're looking for multiples of 3, like, 3, 6, 9, 12. Well, let's put this down. Cube root. I'm looking at that x11. I'm going to say the biggest perfect cube there would be x9. What's left over? X squared. Now I'm looking at y14. I'm going to say y12. It's a multiple of 3. What's left over? Y squared. Now, if I look at Z, 15, 15 is a multiple of 3, right? So what I'm going to do is I'm going to pick the cube root. Now, for some students, I want to point out, they'll think of this as an exponent, 1/3. Well, 1/3 of 9 would be 3. We'll check the answer key later. All right, and then again, think of this as an exponent, 1/3. 1/3 of 12 is 4. So forth and so on. 1/3, again, we're thinking this is an exponent. 1/3 of 15 would be 5. Cube root of x squared, y squared. Okay, let's take a look at the answer key, see if you can agree with it. And the answer key there is for a reason. We want you to look at it. And I'm certainly looking at it. I feel good about that. Let's go to number 4. I know these are difficult. We're trying to encourage you to try them. And what do I see there? It looks pretty nasty. It's a division problem. That's the top. There's nothing wrong with the top, by the way. There is something wrong with the bottom. And I want to tell you what's wrong with the bottom. Whoops, I did it again. That's 5 root y. The bottom has radicals in it, and we can't have radicals in the bottom. So what we're going to do is multiply the top and the bottom by the bottom's conjugate. And this can get pretty nasty. I will say this, over time though, the bottom should be super easy to do. But I'm going to go through it. And what do you get? 2 times 2 is 4. I'm using a distributive proper multiplication, but I'm just doing the bottom. 2 times 2 is 4. Root x times root x is x. So I get 4x initially. And then what do I get? 2 times 5 is 10. Root xy. All right, so I just finished this distribution, this guy across those 2 terms. Now I'm going to do this guy. What does it give you? Minus 10 root xy minus 25 root y is just going to be y. What's nice about this, the 2 middle guys just simply disappear. That's the whole reason for conjugate. I no longer have a radical in the bottom. And of course, I got to do the top. And let's go through it. 2 times 2 is 4. Root x times x is x. Plus 10 root xy minus 8 root xy minus 20y. Again, we have an answer key. Mistakes happen, but we want to see if we can write this down. What's on the bottom? 4x minus 25y. The bottom's done. Let's look at the top. I'm going to say 4x minus 20y. I'm going to get those radicals. 10 minus 8. They have identical radical variable part. So that's going to be plus 2 root xy. What am I doing? I'm adding their numerical coefficients together. Let's look at the answer key and see if we got the right answer. All right, so I'm seeing the 4x. I'm seeing the minus 20y. I'm seeing plus 2 root xy. And at the bottom, I'm seeing 4x minus 25y. I'm comfortable. Going to move on to the next question, which is number 5. What's number 5? Well, we got 2 root 18 x squared y cubed minus xy root 50y. All right, let's go through it one step at a time. And again, over time, you're probably going to be faster. 18 contains a perfect square. It's 9. So 9 times what? 9 times 2. X squared is a perfect squared, and y cubed contains a perfect square, y squared. Let's keep going. I'm looking at the 50. It contains 25 as a perfect square, 2y. Let's do this. 2. What's square root of 9? 3. In this classroom, the square root of x squared is x, and the square root of y squared is y. We left off with the root of 2y. Let's do the next one, xy. What's the root of 25? Is 5. And what he left off with, root of 2y. 6xy root 2y minus 5xy root 2y. Now I'm going to outline this again for you. Identical, variable, radical parts. What we're going to do, add their coefficients together. 6 minus 5 is 1. Well, 1 what? One of these things, which is xy root 2y. Answer key, look at it, make sure you're staring at that. And of course we are. Let's look at number 6. Again, relatively simple questions if you studied the material. I'll put down number 6 for you. This is the cube root, 25 times the cube root of 5. Well, I'm going to pull them together. And what do you get? Cube root of 125. What's cube root of 125? 5. Look at the answer key, 5. We're done. Let's go to 7. What's 7? It's a multiplication problem. 1 minus 2 root x, and then 2 minus 3 root x. Distributed product multiplication. The 1 is going to distribute across these two terms, and then this is going to distribute across these two terms. Let's do one at a time. 1 times 2 is 2. 1 times minus 3 root x is minus 3 root x. Now I'm going to do minus 2 root x times 2, which is minus 4 root x. And then minus 2 times minus 3 is plus 6. Root x times root x is just x. Let's write down what I'm seeing. I'm seeing 2 plus 6x, and then the two internal terms combined together. And what do you get? Minus 7 root x. Put a box in that. I'm going to get my red pen out. I'm going to look at their answer. 2 plus 6x minus 7 root x. Let's go to number 8. Again, people look at number 8 and say, what do you need to do? There's a violation, and you should know about the violations at this point. We can't have a radical in the bottom. So what I'm going to do, I'm going to multiply it by a y. And what do you get? Root 2, which would give me root 2 on top, root 4 on bottom, which is 2. No violations. Look at your answer key. Make sure you're staring at that. And I am. Let's go to number 9. And what's number 9? 3 over root 5x. Same story, a violation. Multiply the bottom by root 5x and multiply the top by root 5x. What do you get? 3 root 5x. On the bottom, you just get 5x. All right? So I'm going to look at the answer key, make sure I'm staring at that answer. And if I'm not, I'm going to say I probably either copied wrong or did something wrong. But I'm seeing it. I feel good about that. Let's put number 10 down. And number 10, let's see, 12 x squared. That's not a problem. I got the 4th root of 27x. Well, this is not a square root, it's a 4th root. You know, the bottom by the 4th root of something and the top by the 4th root of something. My goal is to get a perfect 4th. Well, I'm looking at 27. I'm going to say 81 would be a good match for that. So what do I do? What times 27 by 81? 3. Oh boy, I got to get x to become x4. Well, I'll multiply by x cubed then. Let's write this down. You get 12 x squared, 4th root. This is the top, 3x cubed. What do you get at bottom? 4th root. It's more difficult, so I'll write down the steps. 81 x4. Let's keep going. 12x squared, 4th root, 3x cubed. The 4th root of 81 is 3, and the 4th root of x4 in this classroom is x. It can be reduced. 3 goes into 12 4 times. One of the factors of x would cancel off, so there's x squared over x would be x on top, and then the 4th root of 3x cubed. The box in this. Get my red pen out and see if I did it. Let's see what happens. And I'm seeing 4x, 4th root of 3x cubed. All right, let's go to number 11. I write this down for you. And 11. What's 11 say? It says 10x over the cube root of 25x squared. Well, I need to make a perfect cube. I'm multiply the top by a cube root and the bottom by a cube root. What times 25 would make it a perfect cube? 5 would make it 125. Oh, then I got to do x now, right? Because x times x squared is x cubed. What do you get? 10x cube root of 5x. And on bottom, what do you get? Cube root of 125 x cubed. 10x cube root of 5x. The cube root of 125 is 5, and the cube root of x cubed is x. Let's do a little reduction. 5 goes into 10 two times. The x's cancel. I'm left with the cube root of 5x. Get the red pen out, look at the answer, and certainly we can agree with that answer. It's one that's listed in your blue area of your notes. Let's go to number 12. Again, I realize for some students this may be going too quickly because they haven't studied or done the homework yet. What's 12? It's 1 over 1 minus root of 2. I'm going to multiply the bottom by its conjugate, which is 1 plus root 2. If you multiply the bottom by 1 plus root 2, you must multiply the top by 1 plus root 2. Well, top's really easy to do. It's 1 plus root 2. But again, a bottom, 1 plus root 2. I'm using the distributive property multiplication, minus root 2, minus, well, root 2 times root 2 is just 2. Well, what do you get on top? 1 plus root 2. On bottom, the two internal terms disappear, and we're left off with 1 minus 2, which is just simply minus 1. You're expected to divide through by minus 1. You'll get minus 1 minus root 2. Look at the answer key, and you should be staring at that. It's in the blue area. Go to number 13. And what do you see for 13? 5 over 3 minus root 3. Again, I'm going to multiply the top and the bottom by the bottom's conjugate. What's the bottom's conjugate? 3 plus root 3. When you get there, let's do the top first. 5 times 3 is 15 plus 5 times root 3. What do you get on bottom? 3 times 3 is 9 plus 3 root 3's. Yes, I'm using the distributive property of multiplication. Minus 3 root 3's minus 3. Let's keep going. 15 plus 5 root 3. The top's pretty easy. The bottom's also easy. These two internal terms disappear, and 9 minus 3 is 6. Well, I'm going to write it down a little differently. And when I say differently, maybe leave it at that. I'll put this over here, put a box on it. I want to point out, you could also write this down. And what would you get over there? 15 over 6 would be what? 5 halves plus 5 root 3 over 6. Now let's go to the answer key. Let's take a look at it. And you're seeing this, you're seeing this, and you're seeing this. Again, there's no need to simplify beyond that. That's fine. Let's go to 14. You should appreciate that these problem sets should go very quickly for you once you've mastered the material. It's going to be a square root of 9y cubed minus square root 16y cubed plus y square root 9y. Well, one step at a time. I'm seeing perfect squares. I'm getting better at this. So it's going to be 3, square root of 9. And y cubed contains a perfect square, y squared, and the square root of y squared in this classroom is y. Next up, square root of 16 is 4. Well, the same story. It's going to be y root y plus y, right? Square root of 9 is 3 root y. What do I notice? Every term has identical variable and radical parts. Just add their coefficients together. Well, 3 minus 4 is minus 1, and minus 1 plus 3 is 2. 2 what? Whoops. 2y root y. Let's get the red pen out, see how we did. And again, also I can encourage you to look at the answer key, and you should be staring at that. And we are. All right, let's go to 15. And what's 15? It's 3 over 2 minus root 5x. Again, I'm going to multiply the top and the bottom by the bottom's conjugate. Top is fairly easy to do. You get 6 plus 3 root 5x. The bottom also is very simple. With practice, you probably do this very quickly. Let's go through the steps. 2 times 2 is 4, plus 2 root 5x, minus 2 root 5x, and then you get minus 5x. All right, what do you get on top? 6 plus 3 root 5x. What do you get on bottom? Well, again, it's nice. The two internal terms disappear. We're left off with 4 minus 5x. Put this in a box. I red pen out, look at the answer, and I'm seeing it. All right, let's go to number 16, a little more complicated, but I still think we can do it. And what do you get over there? 1 plus root x, 1 minus root x. Again, it's a constant theme of getting that denominator rationalized by multiplying by its conjugate. And let's go through it. And what do you get on bottom? Well, you get 1 plus root x minus root x minus x. What happens on the bottom? Those two internal terms disappear, and we get something really simple on the bottom. With practice, you should be able to do that without going through that intermediate step. Let's do the top. What do you get over there? 1 plus root x plus root x plus x. What does that give me? 1 plus x plus 2 root x. Put a box on it, look at my key, and see if I can agree with it. 1 plus x plus 2 root x over 1 minus x. All right, let's go to 17. And what's 17? It's the square root of 45 x cubed y5 over the square root of 15 x squared y. Well, my gut feeling is it looks like it'll be a lot of work. I want to see if it reduces, though, before I do anything. Not that it's guaranteed to work, but it looks pretty good to start with. 45 x cubed y5 15 x squared y. And I notice now it does reduce. What we left off with? Well, 15 goes into 45 3 times. And two of the factors of x cancels off, and you get x on top. And then you get, y5 top, y and bottom. Or we give you y4 on top. And I'm taking the square root of that. Well, I do know the square root of y4 is y squared. So we get y squared root 3x. A box in that. Get my red pen out and see how we did. Y squared root 3x. Let's go to number 18. And write it down. 3 over the cube root of 3x squared. Well, I got to rationalize it by multiplying by a cube root of something. Got to make it a perfect cube. Well, what times 3 make it a perfect cube would be 9, because 9 times 3 is 27, perfect cube. What times x squared make it perfect cube? X. So what do you get? On top, you get 3 cube root of 9x. On bottom, you would get the cube root of 27x cubed. Let's keep going. 3 cube root 9x. On the bottom, the cube root of 27 is 3, and the cube root of x cubed is x. So what do you get over here? The 3's cancel. So you get the cube root of 9x on top, and what do you get on bottom? Just an x. Get your red pen out, look at the answer, and of course we're staring at it. All right, number 19, the last problem. I know it's exhausting. And it's root 3 minus root 5 root 2 minus root 3. Again, same story. There's radicals on the bottom. I'm going to multiply the top and the bottom by the bottom's conjugate. And yep, it doesn't look easy. However, we've been doing enough of these together, starting to realize the bottom's pretty easy. What are you going to get? 2, because root 2 times root 2 is 2. On the end, you would get minus 3, and the two middle terms would disappear. Right, we'll do that later. What do you get on top? Distributive property. Root 3 times root 2 is root 6, plus root 3 times root 3. Am I copying that right? Is going to be 3, minus root 5 times root 2 is root 10, minus root 5 times root 3 is root 15. What do you get over here? Well, it looks pretty nasty, but I hope you realize the bottom's just minus 1. The top is 3 plus root 6 minus root 10 minus root 15. Here's my problem. I got to divide through by minus 1. Let's go through it. Root 15 plus root 10 minus root 6 minus 3. Let's take a look at the answer key. See how we did. Root 10, a little different order, by the way. Root 15 minus root 6 minus 3. All right, we're done with that. And what I'm going to do now is I'm going to go just briefly back to another screen share with you. And I'm going to go back to the notes. We just finished the problem set. And I just want to go back to Sage. And not that, I think it's important to do that. However, getting your feet wet in this would be something that may benefit you later on. You may not be interested in that's fine too. We're not going to test you on it, nor is it required for the course. If you do move forward though, and you want to move forward to like, to a STEM-related career, when you transfer it for your institution, you would be expected to be able to use a computer algebra system. And Sage is a good example of one. Again, it's extensible. And it's certainly learning this would help you learn other computer algebra systems. So I'm doing the co-calc again. Hope you're familiar with this. You know me, I want to create a new sheet. I'll do that. And what do I want to get? Sage worksheet. All right. A little slow today, isn't it? Let's see what happens. There it goes. All right. So I think you probably know. Hey, listen, I forgot to put reset down. I'll do it, reset. What's that? Clearing out all the nonsense memory that might be there. Let's type in the square root of 18. Let's see what it does. 3 square root of 2, right? That's a simplification, by the way. I want to point out, if you want to know what it approximately is, let me type this in. So if I wanted an approximate, I would do 18.0. And then Sage would say to me, oh, you want an approximate answer to that. And what does it give me the approximate answer to that? There's a difference between exact and approximate. I'm not saying these are equal, but they're somewhat within a level of precision equal. All right. Let me do 1 divided by square root of 2. What happens? Again, shift return. Hey, look, it returns the correct answer. You may not realize that, by the way, but that's really square root of 2 over 2, which is exactly what it should be. And you could simplify it, type this over here, square root. This may seem strange to you. I'm going to type in what I'm seeing. We'll see what happens. X squared. And then, hit the shift return button, and it returns something to me. Did I type in that right? Yeah, I did. You notice it didn't do anything to the square root of x squared. All right, so I'm gonna type in the next line of code. The next line, whoops, sorry about that. Next line of code said, assume x is greater than 0. In other words, a positive number. Now, when I go through the notes, I'm always telling you that, things may not be entirely true unless the x is a positive number, right? So I'm going to type in now the same problem we did before, which was, I'm sorry about that, which was the square root of 18. Let's see what happens. Star x squared. And now the machine is assuming that x is a positive number. The shift return. And what does it give me? It gives me what I expected, what we're telling you, math 100. The assumption of math 100, though, is the variables are nice if they're positive numbers, right? Particularly for the square roots or even roots. All right. So we're good to go. And what does that mean? We're done with that section. We'll move on to the next one next time. Here's the deal, though. Make sure you can do this on your own. Not the Sage part. We're not going to test you on that. It's the stuff that we're covering in class, though. Good luck.